Hi guys, welcome back to Data Every Day. Today we'll be looking at a dataset of food choices, actually choices from college students. Basically we have a number of students and basically a bunch of data about their food preferences. And at the end of these 61 columns we have a weight column, and we'll be trying to predict someone's weight based on what they say about how much they eat. So this was done from a survey of college students, so we can't guarantee that this data is entirely accurate, and we can't. We also, it says that it's raw and uncleaned, and that maybe we'll have to do some substantial cleaning on this. But let's hop in. One second, let me just pull this up, just like that. Okay. And I have the task for today. Given data about different people's food preferences, let's try to predict the weight of a given person. And we'll be using a TensorFlow artificial neural network to make our predictions. So here I have some imports. It's NumPy, Pandas, Plotly Express for data visualization, standard scalar and train test split for the pre-processing the data. We'll use TensorFlow to construct our model, and then we're just using this metric from TensorFlow add-ons to see how our model's performing. Alright, and so, well, let's take a look at the data. We can read it in using Pandas read CSV. And we can grab the file path right over here, copy file path, paste it in, and we'll take a look. So, first I notice that we have this. What this is saying is we can't see all the columns because there's too many. So what we can do is go into the console and write pandas.set option max columns none. And there, if we reload it, you can see now we will have all the columns, all 61 columns. Alright, so there's a few things we should do. First, let's check about null values. Alright, so say pre-processing, and we want to see how many missing values does this data have. It's sum. Alright, and again we cannot see all the rows. So let's look at the length of this, 61. Let's go into here and do pandas.set option max rows this time, and we'll just give it 61. So now if we run this, we can see all of them. And it looks like not too many. Okay, there's a few here with a large number of nulls, and the reason I consider this large is because we really have very little data to work with, 125 rows. So anything with over 10 is actually like substantial. You know, it's not crazy, but what I would do, I think, is any one of these that has 10 or more and is not numerical, we can just drop. Because we have a large number of columns, it's just going to be, especially like these ones here, we're probably not even going to use these columns because they're sort of customized responses, and it would take a lot of, we'd have to employ a variety of methods to try to turn these into usable features. So most of these things where people just input their responses, I'm going to drop because it will be difficult to use in the model. So let's take a look. Let's see, what should we do? Let's take a look at which of these columns have a large number of nulls and also have non-numeric entries. So we can create a list. Actually, what we'll do is take this isn't a thing dot sum that looks like the same thing, but we'll index it. Well, actually, if I say how should I do it? There's a number of ways to do this, but I think if I just do greater than or equals to 10, that will give us true whenever we have more than 10 null values in a given column. And so this can actually serve as an index. What I mean by that is if we use this as the indexer, and we index at this thing, we'll get just a subset of the NA columns in which we have more than 10 entries. And now we want to see which of these has non-numeric entries. So it's calories underscore day, calories day, comfort food, reasons coded, cuisine, exercise, and type sports. And what we can do is do dot index on this, and why don't I put it in parentheses so we can see what we're doing. This will be just the names of the columns. So if I do dot dtypes, actually that's not going to work. I wonder if does this work? Dot dtypes here. No, it's not helping either. Okay, so index, and then we can index this in data. So we use that index as the indexer for data. Now we have just these columns, and we can see which ones are numerical. And type sports is the only one that is non-numeric. So why don't we go ahead and drop type sports? Okay. Well, before we drop it, we should probably see. Yeah, there's so many unique values. We're just going to drop this. It'd be one thing if they were given some options to pick from, and there's a very small number of unique values. But I mean, we could technically use this as a feature, but I'm just going to drop it for our purposes. So data.drop just what type sports axis 1, and that should do it. So we now have 60 columns, and we haven't really done much. But what we should do next is try to fill in the missing values for the numeric columns. So I'm going to create a list. It's going to be a list of columns for every column in data.columns. So basically for every column, but only if a given column, a given column's data type, so data.dtype subcolumn, is not equal to object. So that means if it's numeric, and the sum of NA values in that column is not 0. So this is saying a list of all the columns in which we have some amount of null values, and we have numeric values. So I'm going to call this numeric nulls. And if we just look at that, you can see it's a good number of them. But now all we have to do is, for a column in numeric nulls, data subcolumn equals data subcolumn dot fill NA with data subcolumn dot mean. So here I'm going to get the mean of each of these columns and then fill all the missing values in that column with the mean of that column. So the mean is calculated excluding missing values. So this should be just fine. Run that. Now if I look at the NA values, I should only have NA values left for non-numeric columns. So how are we going to deal with those? What I'm going to do is make a dictionary. It's going to map a column to a list of the unique values in that column. And this will give us an idea of what kind of data remains in the columns with null values. So I'm going to say for no, not for, sorry, if, sorry, I didn't complete this. For column in data.columns. So that just means we're using all columns here, but only if data.dtypes, no, sorry, data.isNA.sum subcolumn is greater than 0. So this is just all the remaining null columns, let's see what kind of values, unique values, that they contain. And you can see we have GPA, which looks like it should be numeric, but there must be something in here keeping it from being numeric. And you can see some people did not want to answer, and other people decided to include their own little additions to the data entry. So these three need to be dealt with. And that can be considered a numeric column. But the other ones, let's see. So comfort food has a lot of different values, and using these, although they may be useful features, for our purposes, this would just take a long time to process. I'm just going to drop this column. So yeah, I don't see us using this column. Diet current. Also, this is like personalized responses, not going to be helpful. I mean, at least we're not going to be using it. And eating changes, also a personalized response, so we won't be using that either. Trying to see, is there anything else? Father profession. This one we could use, but it depends on how many there are. Yeah, there's a lot of different possibilities here. So we're not going to use that either. Favorite cuisine. I wonder, yeah, we're not going to use this either. And food childhood. Oh, there's actually quite a few left. These are all looking very not promising. They're all full of unique values. Oh, what's this one? This is numeric. Weight. This is what we're trying to predict. So weight and GPA need to be dealt with first, I think. So let's just do that. So for GPA, the things keeping it from being numeric are these three values, right? So what I'll do is I will, let's see, I'll just replace. So data sub GPA dot replace, and I'm just going to do for each of the, so if it has, if it doesn't contain useful information, we're just going to make it null, and if it does, we're going to just change it to be just the useful information. So what this would look like is the same thing, except you can't see it, but it would replace personal with a null value. So we'll do the same thing for unknown. Oh, sorry about that. And then still flickering. Oh my god. Okay. And then we're also going to replace this guy with just 3.79. And I also noticed personal has a space after it, so I gotta include that. And then I want to actually set the column equal to these things. Alright, run that. Now this should have been updated, right? Oh wait, no. Okay, so data sub GPA equals data sub GPA dot as type numpy dot float. So now we're actually going to convert it into a numeric column, and now it should be gone from this list. Wait, it's still here. Oh. It's because I have, I'm only looking for null values here. Alright, give me 1 second. Alright, so after we convert to a float, we also should just fill the mean like we did with the other ones. So data sub GPA equals data sub GPA dot fill NA with data sub GPA dot mean. And run that. Now we should be able to see. Okay. So let's just start dropping these. Actually, we can deal with weight first. Right. So weight has a few problems. I'm not answering this. Not sure, 240, that retains some information. And because this is what we're trying to predict, we're actually going to drop this. We're not going to turn to a null value. We're going to drop the row that contains that, because there's no point in trying to predict a imputed value, right? It's not even real data. So that's only one row, but we're going to have to drop it. This one can just become 144, and this one can be 240. All right, so what are we doing here? Let us remove all of these text columns first. So there's a lot of them, and I just don't see a single one in here that we're going to actually use just for our purposes. So I guess what we could do is just count them up. Actually, what we'll do is make a list, and this will just be here, I'll grab this same code from numeric nulls, or make a few changes to it. So instead of looking for null values, actually this is correct, right? Oh right, no, this is the only thing. We want non-numeric values with nulls. That's what these are. So we can say non-numeric nulls equals this. But there's a problem. We have to remove weight, because weight is not actually, we don't want to drop that. So we'll run this, and then we'll say non-numeric nulls dot remove weight. I think that should work. And then we'll check it after. It should have all the, yeah, it has all of these column names except weight, which has been taken off. And then we can say data equals data.drop non-numeric nulls from axis 1. Alright, now we have all numeric values, and the only thing we have to worry about now is weight. So, okay, let's see. So we have to deal with these particular values. If I run this, I should only get weight. We can see what we need to do. So we want to drop anything like this, right? So instead of doing that, I'll just write down here data sub weight dot unique. We can see them here. So first we'll do data sub weight dot replace, and we're going to replace not sure 240 with 240. And I'm keeping it as a string because we're going to just convert it later. Doesn't matter. And that will be like this. And then we'll do the same thing here. 144 pounds. So I'll grab this. It's just going to become 144. And at the end, what I'm going to do, okay, so what I'll do is temporarily, so actually, one more of these, except I'm going to replace I'm not answering this with a null value. And then I'm going to say data.drop, drop NA. So this is now dropping from the whole data frame any NA rows. Before I do that, I just want to make sure that we don't have any more NA values. Let's put that up here. Right, okay, no more NA values except for weight. So when we drop the rows, we're only going to be dropping from weight. We actually have 2 in there, but that's okay. So we'll be dropping 3 rows total, I believe, because now we're going to turn this one into another null value and drop them all. Alright, so drop NA, axis equals 0, data equals this. So we're dropping any rows that have null values, and we're also going to reset the index afterwards so that we don't, and we'll put drop true so that we don't add the old indices as a new column. And yeah, we reset the index because we don't care about the ordering here. Alright, now data.isNA.sum. I'm going to sum twice over it so we can get the total number of null values, and it's 0. So we're done with nulls, and we're all in numerical form, so we're ready to split and scale the data. So let's look at it. It's all numeric, no more nulls, nice and clean, ready to go in. So we're going to split into x and y. Y is going to be data.loc weight. Alright, so just the weight column, that's what we're trying to predict. And then, oh, I should also do one more thing. Data equals data.asType numpy.float. That will convert the whole thing into purely numeric data, so we don't have any strings lurking in there anymore. Alright, and now, so we're making, y is just going to be the weight, and x is going to be everything except the weight column. Alright, now we'll create a scalar object using the standard scalar from sklearn. That will give each column mean 0 and variance 1. And we're going to scale x. So scalar.fit transform x. Alright, now if we look at x, well, I'll do it as a data frame. Now all the data has been scaled appropriately. And what else are we going to do? We're going to split it using the train test split function to get a train and test set. So x train x test y train y test equals train test split x y. We'll give it a train size of 70%. Whoops, 0.7, and include a random state because this function shuffles the data as well. By including a random state, we can reproduce the shuffle each time. How about 22? Alright, so ready to train. Alright, so I'm going to look at the shape of our input. 48 features in total. So, when I compile, I'm going to start building the model, actually. Inputs equals tf.keras.input. Shape is going to be a vector of length 48. And we're going to have two hidden layers. One will be a dense layer with 64 activations and a ReLU activation function, passing in inputs. And then we'll have an identical layer, but we'll pass in x. And for our outputs, we'll have another dense layer with only one output and a linear activation, which is just another way of saying no activation, passing x. And we'll create our model using the inputs and outputs. And we'll compile it. So for an optimizer, I'm going to use Atom. Loss function will be binary cross entropy since, wait, sorry, no, not, it will be MSE. We'll just use mean squared error since this is a regression task. And I'm not going to include a metric because I want to deal with the metric afterwards because we're using the R squared metric. I'm just going to see how it does on the test set. And we'll include a batch size and number of epochs. History equals model.fit x train y train, and we'll give it a validation split of 20%, including the batch size and epochs here as well. Alright, and we will train this, and then we will also plot the results while it trains. So I'll use Plotly Express. So fig is going to be px.line for a line chart. And we're going to draw information from the history.history. History has a attribute called history, which we can index at various metrics and loss functions to get the values of them across the epochs. So y is going to be the metrics we want, in this case actually losses, loss and val loss. Then we'll give it some labels. X will become epoch, y will become loss. The title, loss over time. We'll do fig.show, see how it went, and you can see both the validation loss and the training loss continue to go down over the course of the training. So at the end, let's see how our model performed. So at this point, we can only evaluate the model using the loss, which isn't really a great way to evaluate it. So let's use r squared to get a better idea. So I'm going to create an array of predictions. So ypreds will be model.predict on the test set xtest. And this will return an array of length m by 1, where m is the number of training examples. So if we're going to compare it to ytest, which is actually just a vector, we want to use numpy.squeeze on it to get rid of that extra dimension that we don't need. So that's our predictions, and then we're going to create, I think at the top we imported r square from TensorFlow add-ons.metrics. So let's call little r square a new instance of r square, and then we can update the state. So r square.update state. So this is basically just show us what are the r squared values between the test values and the predicted values. Alright, and then we'll print out the result. So r square score colon will be r squared dot result, and then also dot numpy to get the value as numpy. And we have an r squared value of negative 2.5, which is terrible. This should be usually r squared takes values between 0 and 1, where 1 is the best. But if it's really bad, it can go into the negatives. Let's see if we can do anything to our model to try to improve this. And something I noticed when experimenting with this is that this is actually it's too simple of a model. It's underfitting our data. This isn't able to capture the the deeper complexities and patterns that are in this data set. I think if we had more data and not just 125 rows, we'd be okay. But it seems like by adding, I found the best performance came by adding 2 more hidden layers. So 2 more, and then increasing these activations up substantially. 256, 512, 512, and 256, respectively, gave us a much better loss and r squared value at the end. So we end up with a negative 0.14, which is much better than negative 2.5. Still not great, still pretty bad, but based on the data we had, this is reasonable. If any of you have ideas of how I could further improve the model, I'd be happy to hear them. So I guess that sums up today's video. If you enjoyed it, make sure to subscribe and hit the bell for more content, and leave any comments you have in the section below. Thank you so much for watching. I'll see you guys tomorrow. Have a fantastic day.